Right, so in this video, I'd like to talk about more translation work of taking word problems and then putting them into algebraic expressions. So let's use a restaurant kitchen as an example. Let's say that there's K people in a restaurant kitchen. 25% of them are chefs. Let's say 10 people are the preppers who make the ingredients, chop up all of the ingredients so that they're ready for the chefs. Let's say there's 10 people. There's no percentage here. I actually just mean actual people. 10 people, and then 5 people are dishwashers. And there's tons of other folks who work in a kitchen. So we'll call that category everyone else. You know, the managers, the people who order the food and keep the food warm and all that kind of stuff. So let's say that there are 4 broad categories here, and we want to figure out, well, not figure out, but we want to describe in terms of K, how would you describe everyone else in terms of K? Well, what we would do is, and so that's what we want to see as our expression. What we would do is we would add up these different categories and then subtract it from K, because whoever's left over will be everyone else, okay? So that's basically what we're doing. So let's do that. So 25% of K are chefs. So we represent that with 0.25 K. So this is 25% of K. So of means multiplying, so you're going to multiply these two. And you can't multiply 25% as a percent. You need to turn it into decimal form. So 0.25K represents the chefs. Okay, 10 people are the preppers. So we're going to actually just, I'll write it over here so I have more room, 0.25K. And then since 10 is an actual number of people, we're just going to write 10, all right? And since 5 dishwashers is an actual number of people, we're just going to write 5. So let's add all of this up. So we have 0.25K, and then 10 and 5 are like terms. They're constants. You can add them together. So you would get 0.25K plus 15. This expression right here represents these first 3 categories. So if you want to figure out, or at least describe, everyone else in terms of K, what you're going to have to do is you're going to take K and you're going to have to subtract everything in these 3 categories, okay? So this is these 3 categories, and you subtract it from the total amount of people, which will give you who's left over, which is everyone else. This is a really important thing here. Did you see that I put this into parentheses? Super important that I put in parentheses, because I want to subtract all of this from K. All of it from K. If I did not put the parentheses here, then all I would be doing is just subtracting the chefs from K. But I want to subtract all of the people from K, all at once. Okay, so it's really important that you put this parentheses in. So now I need to combine like terms. I have K and K here, so I can combine those. But in order to do that, I need to take away the parentheses. How do I take away the parentheses? I need to distribute. This is super crucial. Do you see that this negative is basically touching this parentheses? So this negative out here, I'm going to put it right over here, because there really is also a 1. Whenever you don't see a number here, you can always put a 1. 1 times anything just gives you what that anything is. So this negative right here is really a -1. It's so important. This is so crucial to this. So now when you distribute, you need to distribute this -1 over all of the terms in the parentheses. Okay? So to take away the parentheses, I can only do so when I distribute -1 over everything. So this is going to be negative, or subtracting, 0.25K. And then this is going to be negative, so -1 times 0.25K is negative 0.25K. And then negative times negative, negative times this positive, see this -1 times 15, is going to end up with -15. Okay? So now I have an expression without any parentheses, and I can combine like terms. K minus 0.25K is going to be 0.75K. plus negative 15. So this is my simplified expression. So this is how we describe everyone else in the kitchen who is left over from because they're not in one of these three categories. Okay. Let's try another problem. Let's say that we have two different people with two different ages. So let's say that Betty is a quarter, 1/4, 1/4 of Wilson's age. Okay, we don't know how old Betty is. We don't know how old Wilson is, but we know relatively how they compare. So Wilson is 4 times older than Betty. So if Betty was 20, Wilson would be 80. Okay, all right. Let's also say that in 15 years, Betty will be X years old. She's not X years old now. In 15 years from now, she's going to be X years old. The question is, how old is Wilson right now? How old is Wilson right now? Well, let's figure out how old Betty is right now, okay? So we know that even though Betty is not X years old, in 15 years she will be. So we can take Betty's X age in 15 years from now, subtract 15 from it to get Betty's age now. So Betty's age now, Betty now is what Betty will be in 15 years from now, minus those 15 years to get back to now. So this is Betty's current age. Future age minus 15 is her current age. Okay, we also know that Wilson is 4 times Betty's current age. So if we take Betty's current age, the whole thing, again, this is why parentheses is so important, just like in the last problem. You got to put in parentheses. If you take Betty's current age and put in parentheses and multiply it times 4, you're going to get Wilson's age. Okay? So now, because we have a parentheses here, we can distribute. Okay? So this is going to be 4x minus 4 times 15 is 60. So Wilson's current age is 4x minus 60. Okay? I suppose you could leave it in this form as well, but this is, I think, a better, more simplified form. So 4x minus 60 is Wilson's current age. All right, lastly, let's say that we have some pencils, some coloring pencils, okay? All right, so let's say that we have blue pencils and that we've got green pencils, okay? Now, let's say we have a ratio of blue to green. We don't know how many blue and how many green we have or how many total we have, but we do know at least the relative ratios of them. So, so we have 4 blue for every 5 green, okay? So the ratio of blue to green is 4 to 5, okay? So we have more green than blue. We don't know how many that is, but we do know that this is the relative ratio. So, meaning if we did have 4 blue pencils, we would have 5 green. If we had 8 blue, then we would have 10 green. If we had 12 blue, then we would have 15 green. You see, I just need to multiply the top and the bottom times the same amount. There's always going to be that ratio representing the 2 amount of colors. Okay, so the question is, let's say that right now, there are exactly, let's say, 4m plus 8 blue markers. Blue pencils, sorry. Blue pencils. So this is the current amount of blue pencils. Okay. What is the current amount of green pencils? That's the question. What's the current amount of green pencils? So in terms of M, because again, we don't know exactly how many blue pencils there are even now, because we don't know what M is. But let's come up with a representation in terms of M of how many green pencils there are right now. Okay, so what I would do, you could use this solving a proportion, where you're cross multiplying in proportions. We haven't learned that yet, so we're gonna stick with the bar model. So here's a bar, and let's chop it into sections. How many sections? Let's chop it into 9 sections. Why 9? Well, we know that there's 4 sections of blue and 5 sections of green, and we only have blue or green pencils. So this is the total amount of pencils, and we know that there's 9 sections, okay? So let's say that's, let's see if I can do this relatively okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. Okay. So let's say we have 9 sections. We know that 4 of them, I wish I actually had coloring markers, but let's say the shaded ones here, these shaded 4, are going to represent the blue. And we also know that currently blue can be represented by 4m plus 8. Okay? 4m plus 8. So this entire quantity right here is represented by 4m plus 8. So now we need to figure out this part, because what's left over is the green. We have 5 green. 1, 2, 3, 4, 5. So this is the green section. I hope this is still on the video. Oh yeah, just barely makes it. Okay, so these are the green section. Okay, so here's what we can do with the bar model. You see that there's 1, 2, 3, 4 of these sections within blue. And do you see that this is what blue is? Like this whole, all 4 sections amount to 4m plus 8. So what we could do is this. We could divide 4m plus 8 by how many sections there are to figure out what just one section is worth. And since each of these sections, even on the green side, are all the same size, or they're supposed to be, even though I didn't, I did the best I could by making them equal. So if I just knew what one block was, then each of these blocks, the whole way down, would be the same amount. Each of these blocks would be the same. And then all I would need to do is add up 5 of these blocks, and voila, I would have all of the green that I've got. So now the question is, how much is just one block? I know what 4 blocks is. That's 4m plus 8. But what's just one block? How would I figure that out? Well, I would divide this by how many blocks it's worth. So this is worth 4 blocks. So 4m plus 8 needs to be divided by 4 just to get one of these blocks. Okay? So what's a quarter, 1/4 of 4m plus 8? Well, that would be 4 goes into 4 once, so that's 1m. 4 goes into 8 twice, so that's 2, and you don't need this 1. 1 times m is just m. So each block is m plus 2. This is m plus 2, 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 m plus 2, m plus 2. Okay, so all I need to do is, I need to add m plus 2 up 5 times. Okay, well what I gotta do is then just quickly add. How do you quickly add? Multiply. So if I take m plus 2 and I multiply it times 5, I've got my entire green section. And there you go. So if you want, you can also distribute this, so it would be 5m plus 10. So if you want to say it that way, this entire green section, how many green markers do I have? Currently, 5m plus 10. All right, thanks a lot.